Hello everyone, welcome to Mind Academy. So today we are going to start part 2 of MPT exam preparation. In this series, we solved last year question papers of various universities. So we have started with JAMIA MILIA ISLAMIA 2022 question paper. So here we begin with question number 11. First 10 we have already discussed in our previous video. You can just check it out. So let's start. Question number 11. What is residual volume? Option A, amount of air left in the lungs after maximum expiration. Option B, maximum amount of air an individual can exhale after normal relaxed expiration. Option C, the volume in the lungs at maximal inflation. And option D, none of the above. So first we'll check what is residual volume. Residual volume is an amount of air that allows diffusion of gases to continue between pulmonary blood capillaries and alveoli even after forced exhalation. Okay, even after the forced exhalation, there is amount of air that is left which allows diffusion of gases. That is called residual volume. Okay, so as you can see this chart here, we have a inspiratory reserve volume, volume that can be inspired beyond a restful inspiration. That is around 3100 ml. Then we have tidal volume, volume of a single breath, usually at rest. That is around 500 ml. Then expiratory reserve volume, volume which can be expired beyond a restful expiration. Okay, so that's around 1200 ml. Then residual volume, volume remaining in the lungs after maximum expiration. The volume keeps the alveoli inflated. So that is around 1200 milliliter. Then we have vital capacity, the maximum volume which can be ventilated in a single breath. So VC is equal to IRV plus TV plus CRV. Okay, as you can see, the vital capacity. Its value is around 4800 ml. Then lung capacity or the total lung capacity TLC is the volume of air in the lungs upon the maximum effort of inspiration. That is 600 milliliter. So these values are very important because this can come as questions in almost all the MPT entrance exams. So answer for this question will be A. Okay, and that's amount of air left in the lungs after maximum expiration. Okay. So next we'll move to question number 12. Airway clearance technique contains coughing, B, postal drainage, C, deep breathing exercise, and D, all of the above. Okay, so we'll see what is airway clearance technique and what are the steps it has or the techniques it has. So airway clearance techniques or ACTS are ways to loosen thick sticky mucus so it can be curved up and cleared out of lung. Okay, it is mostly a technique through which thick sticky mucus are curved out through the lungs. Okay, so techniques include first ACBT, which has breathing control, thoracic expansion exercises, forced expiratory exercises or techniques. Okay. Next is percussion, which has manual percussion, that is cupping, then mechanical percussion. Cupping in the sense like we'll place our hands in cup position and we'll hit the chest. Okay, not that cupping technique. Then we have chest shaking, vibration compression, gravity assisted positions, autogenic drainage, spirometry, airway suction. Okay, so here are some steps of active circular breathing technique. First is breathing control, where we have relaxed breathing, then deep breathing or thoracic expansion exercises, that is 3 to 5 deep breaths, then forced expiration techniques, half, medium or low volume, then coughing, cough out, expiration. Okay, these are the 4 steps we follow. So as the question says, airway clearance technique has A, cupping, B, postal drainage, C, deep breathing exercise. We can see we have cupping, we have postal drainage and deep breathing exercise. Okay, so answer will be D, all of the above. Okay. Next, we'll move to question number 13. Which valve prevents the flow of blood from the ventricles back into the artery during systole? First, option A, tricuspid valve. Option B, mitral valve. Option C, both A and B. And option D, aortic valve. Okay. So now we'll learn about all the four main valves that are present. So first is tricuspid valve. This valve is located between the right atrium and the left ventricle. It allows blood to flow into right ventricles only. So as you can see here, tricuspid valve, okay, where it is present? It is present between, say this tricuspid valve. It is present between right atrium and right ventricle. Okay, it allows the blood to flow to right ventricle only. Okay, next we have pulmonary valve. Pulmonary valve is located between the right ventricle and the pulmonary artery. Okay, see this one. This is the pulmonary valve, and this is located between the right ventricle and the pulmonary artery. This is the artery. This is the ventricle. Okay, and it allows blood from the right ventricles to go into the pulmonary trunk, but not in reverse direction. So here blood will go in one direction only. Blood will not come back in the reverse direction. Okay. Next we have mitral valve. This valve is located between left atrium and left ventricle. As you can see, these two. This is the valve or the gate which is present between left atrium and left ventricle. It has only two leaflets. Okay, and it allows blood to flow in left ventricles only. So from here, blood will flow to the left ventricles only. Fine. And next we have aortic valve. Aortic valve is located between the left ventricle and the aorta. Okay, as you can see, this is left ventricle and this is aorta. There is a valve present here. It is called aortic valve, and it allows blood from the left ventricle to go into aorta, and but not in the reverse direction. Okay, so the question is that which valve prevent the flow of blood from ventricles back into the artery during systole? It will be both tricuspid and mitral valve. Okay, tricuspid valve it's here and mitral valve it's here. So what happens is during systole, blood that cannot flow back from ventricles to artery. Fine. And there is a small diagrammatic representation. You can also go through it. I tried to add more and more diagrams and photos so that it will help each and every student. So let's move to our next question. That is question number 14. Which of the following muscle fiber types is most beneficial for a marathon runner? Option A, type 1. Option B, type 2A. Option C, type 2X. And option D, type 2C. So here is a table containing all the four fibers. So we'll just go through it and we'll get to know. So in type, as you can see in type 1 fiber, contraction time is slow. In type 2A, it's moderately fast. In type 2X fiber, it is fast. And in type 2B fiber, contraction time is very fast. Size of motor neuron in type 1 is small. In type 2A fiber is medium. In type 2X fiber is large. And in type 2B fibers is very large. The resistance to fatigue in type 1 fiber, it's high, fairly high, intermediate, and low in type 2B fibers. Okay, activity used in type 1 is aerobic. In type 2A, it's long-term anaerobic, short-term anaerobic, and short-term anaerobic for 2X and 2B. Maximum duration of use is hours for type 1. For type 2A is medium, less than 30 minutes. Type 2X, less than 5 minutes. And type 2B, less than 1 minute. The power produced in type 1 fiber is low. In type 2A, it's medium. Type 2X high. Type 2B is very high. So accordingly, you can just go through it. So first, we'll know what is the basic characteristic of a marathon runner. You can see in this only. For a marathon runner, they have to cover a large amount of distance. Okay, so that large amount of distance they cannot cover in 30 minutes, 5 minutes, or 1 minute. Definitely, they will take hours. Okay, then since they are doing a long distance running, it will be mostly an aerobic activity, not anaerobic. Okay, and since they are going through a large distance, the resistance to fatigue should always be high. Otherwise, they will get tired easily and they will stop in the mid. They cannot cover their marathon. So, according to this table and seeing all the characteristics of marathon, what is a marathon? The answer will be A, type 1. Okay. So, which of the following muscle fiber types is most beneficial for a marathon runner? So the answer will be type 1. Now, let's move to question number 15. Which of the following is the definition of power? Okay. A, mass into acceleration. Option B, force into distance. Option C, force into velocity. Option D, torque into time. Okay. So first we'll see what is power. Power is defined as the rate of doing work. Okay. It is the work done in unit time. And SI unit of power is watt, which is joules per second. That is J per S. So according to definition, power is the rate of doing work or work done in a unit time. So it will be work by time. And work is equal to force into displacement. So by the formula, it will be force into displacement. Power is equal to force into displacement by time. Okay. Now, if we take the only displacement by time out, then displacement by time will give us velocity. So power is equal to force into velocity. So according to this formula, the answer will be answer C, that is force into velocity. Okay. Hope you understood this. And next, we'll move to question number 16. So question number 16. The mean arterial pressure is defined as option A, average blood pressure throughout the cardiac cycle. Option B, average of the systolic pressures. Option C, average systolic blood pressure during exercise. And option D, average of blood pressure and heart rate. So we'll see what is MAP or mean arterial pressure. So mean arterial pressure is defined as the average arterial pressure during a single cardiac cycle. As blood is pumped out of left ventricle into the arteries, the pressure is generated. Okay. So when blood is pumped from left ventricle to the artery, the pressure will be generated. MAP is determined by cardiac output, CO, systemic vesicular resistance, that is SVR, and central venous pressure, CVP. So MAP is equal to cardiac output multiplied by systemic vesicular plus central venous pressure. As CVP is near to 0 mmHg, relationship can be simplified as below. Since CVP is nearly 0 mmHg, okay, so the normal formula will be MAP is equal to cardiac output multiplied by systemic vesicular resistance. And what is the clinical significance of MAP? MAP is better indicator of tissue perfusion than SBP. Hence, MAP is calculated for the management of patients with acute conditions when there is a concern for appropriate organ perfusion. Okay, so from the first line only, we come to know that mean arterial pressure, MAP, is defined as the average arterial pressure during a single cardiac cycle. So answer will be answer A. So question number 6, the mean arterial pressure is defined as, the answer will be option A, average blood pressure throughout the cardiac cycle. So next move to question number 17. Question number 17. Which of the following is an example of an isokinetic muscle action? Option A, lifting a barbell in a biceps curl. Option B, lowering a barbell in a biceps curl. Option C, exerting force against an object that does not move. And option D, a movement during which the velocity is held constant. So first we'll see about different types of muscle action. So basically there are three types of muscle action. That is isometric, isokinetic, and isotonic. In isometric, means equal. Okay, so it means equal in length. The length of the muscle stays same while performing the activity. Example, plank. When we do plank, the length of the muscles remains same. Then isokinetic action. Kinetic is equal to velocity or speed. So this means the action will be, in this action, velocity will be equal. The velocity of the muscle stays the same while performing an activity. Example, exercise in isokinetic dynamometer. Then we have isotonic action. Here, tone means tension. Iso means equal. So that means equal tension. The tension of the muscle stays the same while performing an activity. So example will be bench press. So answer for this will be a movement during which velocity is held constant. Because in the question you can see example of isokinetic. And isokinetic means constant velocity. Okay, so a movement during which the velocity is held constant. It is the example of an isokinetic muscle action. And what will be the example? Exercise in isokinetic dynamometer. Okay. So next we'll move to question number 18. So question number 18. The primary inspiratory muscles are or is option A, external intercostals, option B, sternocleidomastoid, option C, pectoralis minor, and option D, latissimus dorsi. So as you can see in this diagram, there are two categories, inspiratory and expiratory. In inspiratory muscles, we have sternocleidomastoid. What it does, it elevates the sternum and helps in rotation of the head. Then we have scalene muscles, which helps to elevate the upper ribs. Then we have external intercostals, which helps to elevate rib cage. Okay. Then we have diaphragm. It is the primary muscle of the respiration flow generator. Okay. Next, we have muscles for expiration. First is internal intercostal muscle, which depresses the rib cage. Then we have abdomen, which compresses the abdominal cavity and pushes diaphragm upward. Then external obliquus, contralateral rotation of torso takes place. Rectus abdominis flexes vertebral column, and transverse abdominis and internal obliquus, and then ipsilateral rotation. So, as you can see here, the answer will be answer A. The primary inspiratory muscles is external intercostal, which are these muscles. Okay. Since as you can see, pectoralis minor, sternocleidomastoid, and latissimus dorsi. See, we have sternocleidomastoid here, but this is not the primary. Okay, the primary will be external intercostals. So answer A. Here also you can see there is also a good diagram for muscle of inhalation and expiration. We have diaphragm, external intercostal, sternocleidomastoid, and then scalenes. Then muscle of exhalation, we have internal intercostals, then external oblique, internal oblique, transverse abdominis, and rectus abdominis. Okay, so next we'll move to question number 19. Which of the following is the body's major heat loss mechanism for exercise in the heat? Option A, convection. Option B, evaporation. Option C, radiation. And option D, ventilation. Okay, so major heat loss mechanism for exercise in body. So, as you can see this diagram or photo, heat transfer mechanism, heat gain, heat loss. How is heat gained? Through solar radiation, convection through hot air temperature, then metabolic heat production, then ground heat, that is radiation and conduction. These are the steps to gain heat. Now, how do we lose heat? Evaporation. Okay, that is around 80%. Radiation in the body, and then convection, cooler wind and current. Fine. So if skin temperature is greater than surrounding temperature, heat loss will be due to radiation and conduction. Okay. And if skin temperature is less than the surrounding temperature, heat loss will be due to evaporation. So answer will be option B, evaporation. Okay, because in heat, skin temperature will be less than the surrounding temperature. Okay, so this is question number 19. So one more diagram I've kept here, which will help you to understand the better, because sometimes this also comes in short notes in physiology. So you can just make this diagram, okay, and you can get some good marks, because in exam diagrams are very important. Okay, so next we'll go for the last question for this video. That's question number 20. The duration at QRS complex is option A 0.06 to 0.1 second, option B 0.02 to 0.2 second, option C 0.04 to 0.3 second, and option D 0.08 to 0.4 second. So for that, first we'll have to see what is QRS. So this is from ECG. You can take this one. You can take a screenshot of this, or you can just check our Instagram page. I have uploaded this one. It will help you understand ECG better. So in ECG, we have P wave, QRS complex, PR interval, ST segment, QT interval, T wave, and U wave. Now, what is P wave? P wave represents the depolarization or the contraction of SA node, responsible. Okay. Next, QRS complex. QRS complex represents ventricular depolarization. Okay. Then we have PR interval. PR interval starts at the atrial contraction and ends at the beginning of ventricular depolarization. Then we have ST segment. ST segment, it is known as initial phase of ventricular repolarization. Okay, and then we have QT interval. That is QT interval represents the time for both ventricular depolarization and repolarization to occur. And in waves, we have other two waves, that is T wave and U wave. In T wave, which represents ventricular repolarization, U wave represents, it is not common, but it may be come following the T wave. Okay, as you can see in the diagram, P wave, QRS, then T, and then at the end, U wave may come. Okay, fine. So P wave starts through SA node contraction. Then we have QRS complex, which represents ventricular depolarization. And we have T wave, it shows ventricular repolarization. And then we have U wave, which may be seen following the T wave. Okay. So the answer to the question, what the value of QRS complex, as you can see, it is nearly 0.05 to 0.10 second. 0.05 to 0.10 seconds. So since we don't have that in option, the nearest one is 0.06 to 0.10 seconds. So option A will be the answer. So this is for today. Hope you all learned something and enjoyed it. If you liked it, do like the video, subscribe to our channel, share it among your friends, and see you all in next video for the next set of questions. Thank you everyone, and see you soon.